problem, 33rd problem in JEST exam. Okay, what is the equation of plane which is tangent to the surface x, y, z is equal to 4? Wait a second. Yeah, now I can recall the theorem. Theorem is, so I mean this kind of equation will talk about surface. Okay, some surface. So in 3 dimension. Is that okay? Though x, y, z are related, isn't it? So this kind of equation will talk about some surface in 3 dimension. Then gradient of this phi. Is that okay? So at some point x naught, y naught, z naught. Okay. So this is in the direction of normal or perpendicular. Okay, normal. So drawn to the surface, normal to the surface at point x naught, y naught, z naught. Okay, normal at point x naught, y naught, z naught. Is it clear? Can you have a note? So take it as a note here. Actually, I don't remember in which book I read this one. Yeah, so anyone from online who studied this one already? Yeah, so definitely this is true. Okay, now sometimes they may design the question so that find the normal to the surface at, find the unit normal. Then you have to take gradient. Gradient is a vector. So divide by its magnitude, make it as a unit vector. Okay, that's the one choice. So then again, next point is, you can find equation of tangent plane actually. You can form equation of a plane here using this one. I think I lost that note that I have made yesterday. Yeah, wait a second. Now let me try to so put in my way. So this is the point of interest. Okay, x naught, y naught, z naught. There is one surface. Okay. Now when you take gradient, what would you get? You will get this one. Am I right? So this is gradient of phi direction. Okay. So this surface is phi is equal to some constant. Is that okay? This is the gradient of phi direction. Can you check it out? Am I right about this one? Gradient will talk about normal to the surface. Yeah, anybody from online? Actually, I haven't put this in this way. I mean, our potential formalism can be put in this way. That's correct, okay? Gradient will talk about normal to the surface. Let me get you to the very physical thing in electrostatics. Suppose if you write V of R, that you are going to write 1 by 4 pi epsilon naught, so Q by R, am I right? Now suppose if I take V of R equal to C like that, so that will be on a spherical surface usually. So that's the kind of spherical, I mean spherical is symmetric. Look at here, 1 by 4 pi epsilon naught, so Q by R is equal to C. That means R is equal to some constant, am I right? What is this one? X square plus y square plus z square is equal to some other constant. So that what is this one? This is the equation of sphere, am I right? Now look at here, if you take gradient of this one, what would you get? You'll get electric field. Electric field is perpendicular to the surface. That's radially outward. That's how, again, that was needed actually. In our theory, it was needed, but in Griffiths, he hasn't taken in that direction. Or maybe in outside problem, he might have given this one. Is that okay? We haven't thought our electrostatic in this manner usually. Is that okay? This is equal to constant. That is a equation of a plane. Is that okay? If you take a gradient, you will get electric field. So that is normal to the each point actually. That will be along r cap direction. Okay, can you just imagine that one? Is that okay? You have a surface like this. If you take normal, you will get the direction of electric field. You have charge q here, isn't it? So that's how it works. That's what, again, so that's what I'm just writing in a mathematical form. Okay, quickly. Now look at here. Now what I do here is I'm going to construct one plane on this one. Okay. plane which just touches this point. Okay, this is a point of interest actually. I'm going to construct one plane, so which just touches this point, and that is again perpendicular to this one, obviously. So tangent plane, we call it known as tangent plane. Is that okay? Now what I do here is I'm going to take any one arbitrary vector in this plane, okay, to the point x comma y comma z from x0, y0, z0. Okay, x0, y0, z0 is the point at which the tangent plane is tangent to the surface. Is that okay? At the point where this tangent plane touches the surface. Okay, this is some arbitrary point on the plane. Is that okay? This is some arbitrary point on the plane, and you have, this is the direction which is perpendicular to the plane. Am I right? Now what I do here is I am going to construct this vector. Okay, I am going to construct this vector. I am going to call this r0 vector as x0 x cap plus y0 y cap plus z0 z cap. That is my point on which I am just discussing everything. Is that okay? So now I am going to discuss, I am going to write one more vector. R is equal to x cap plus y cap plus z cap. This x, y, z is any point arbitrarily on the surface. Is that okay? Now look at here, whatever the vector on the surface that is perpendicular to the normal. Whatever the vector on this tangent plane that is perpendicular to this normal. Am I right? So that's why I can write, I am going to write this vector from this point to this point. Either how do you write r0 minus r or r minus r0? Isn't it? If you choose origin somewhere here, isn't it? You can write r0 minus r or something, isn't it? So you can write in any manner, because right hand side I am going to put 0. Wait a second. So look at here. Now what I do here is r minus r0. This is the vector on a plane. This is the point where our plane is tangent to the, so where our plane just touches the, this curved plane, okay, wherever this tangent plane touches this one. Is that okay? So r is some general point on this tangent plane. So r minus r0 dot product with del phi. It should be 0 always. This is the equation of the tangent plane. Are you getting my point? It is one condition. We are defining one condition here that itself mathematically becomes equation of a tangent plane. So there are many questions on this one, frequent questions in TIFR also. Are you getting the logic? Okay. I too forgot much of this theory actually, but I think this is sufficient, okay, to answer those questions. But you should know how it is connected to our electrostatic, okay, our electric field. Now think how electric field become gradient of potential and what is the meaning of that. Okay, this is also another physical interpretation of gradient. We haven't done that earlier, isn't it? Is it clear? Or I can write x minus x0 into x cap plus y minus y0 into y cap plus z minus z0 into z cap, where x0, y0, z0 is the point where we are drawing the tangent plane, is the point where our tangent plane touching that one. That is the meaning of tangent plane. Is that okay? So dot product with del phi is equal to 0. We call this one as normal actually. Okay, this is normal to the plane. X, Y, Z is any arbitrary point on the plane. You can take any other arbitrary point. Remember, these two will be perpendicular. And x0, y0, z0 is the point of interest. And now take this question. You will definitely understand what I am trying to convince here. Okay. It was never needed in electrodynamics theory actually, but it will give little more closer insight towards your potential formalism. As I said, how electric field is designed, isn't it? Electric field is normal to the surface formed by potential equal to constant. If you take potential equal to constant, that will become a spherical surface, and if you take a gradient, that will be normal to the surface, that will be radially outward. You can think like that, okay, mathematically. Yeah. Is that clear? Now look at here, they may ask what is the, now look at here, I hope they will not ask what is the tangent to the surface, because there are infinitely many tangents. That's why we are drawing a tangent plane, remember, isn't it? Only one normal to the surface. If you take any curved surface, is that okay? If you take a point, so you will have only one you will have only one normal to the surface, but you can draw a tangent plane. That means you have infinitely many tangents to the surface. That's why we are going to draw a tangent plane to that one. Is that okay? And that is the equation of a tangent plane. Okay. Now quickly, can you quickly get this one? So he has given x, y, z is equal to 4 is a equation of a surface. Okay. Find the tangent at, find the equation of tangent plane at 1, 2, 2. Since our right hand side is 0, look at here. Since our right hand side is 0, I think you don't have to take what is that? Unit vector. Actually, so you better to make it as a unit vector, unit normal. Usually in mathematics we discuss like that. We are going to take dot product with a unit vector, but it doesn't matter since our right hand side is 0, it doesn't matter. Okay, quickly. So do the gradient. So suppose phi of x comma y comma z is equal to c. That means phi of x comma y comma z, I mean c. That means our x comma y comma z, sorry, x into y into z, that's equal to 4. Am I right? Now what is del phi? Quickly. Dou phi by dou x, dou phi by dou y, dou phi by dou z. Clear? Now this is x naught, y naught, z naught, because he is asking at this point. Okay, you should have, again remember, you should have clear geometrical imagination. Okay, while doing this problem, you should know that this is perpendicular to that. I mean, now look at here. So this is the general gradient. You have to find that gradient at that point to find normal at that point. Okay, so find gradient at 1, 2, 2. Quickly, what is this one? 2 into 2, 4x cap, x into z, 2y cap, plus x into y, 2z cap. Now this is in the direction which is normal to the plane at that point. Okay, because plane have, I mean, so not plane, I'm talking about surface. Okay, normal to the surface. Surface, plane. So differentiate that one. This is the surface. Okay, so whatever we are finding, that is the tangent plane, equation of tangent plane. That's what we are finding. Okay, look at here. The next one. So what is this one? This is x naught, y naught, z naught. X minus 1, x cap, quickly, y minus 2, y cap, plus, okay, dot product with 4x cap plus 2y cap plus 2z cap is equal to 0. Dot product means x coordinate, y coordinate, z coordinate individually multiplied. Am I right? X minus 1, 4 times x minus 1 plus 2 times y minus 2 plus 2 times z minus 2 is equal to 0. Quickly, you have to see the option now. Yeah, he has taken constant that side, 4 plus 4, 12 that side, 4x plus 2y plus 2z is equal to 12. Check it out. 4x plus, divide by 2, 2x plus y plus z is equal to 6. Yeah, that's the last option. Can you just open last question in TIFR, last 2 questions? They are again like this. Very simple. You have to remember this one, okay? R minus R naught dot gradient at R naught, okay? Don't forget, because gradient is a general vector field, okay? You have to take one vector which is normal to the plane at that point, okay? That is equal to 0. This is the equation. Obviously, that is a condition. That's a condition. I mean, that is the not condition. What we say, that is the situation that we are defining. If this is tangent plane, if this is normal, dot product between this vector and any vector on the plane is 0. That's what we are writing. It's one situation. Is that okay? That itself will give equation of a plane. Again, this is 33rd question in TIFR, okay? TIFR paper. 33rd question. Which of the following vector is parallel to the surface x square y plus 2xz is equal to 4 at 2 comma minus 2 comma 3. Look at here. Which of the following vectors is parallel to the surface, okay? That means first you know how to find perpendicular to the surface and take a dot product with each. Is that okay? The dot product which gives 0, so that is perpendicular to that given vector. Or if you can't imagine, just draw that one, okay? Just draw that. Yeah, somewhere here I have, so 2 comma minus 2 comma 3, okay? He is asking any one vector which is parallel to the surface. He should not say parallel to the surface, he should have said tangent to the surface. Because surface is not parallel. Isn't it? Is that surface is parallel? No, it is not parallel. He should have said, yeah, whatever, okay? You should be able to understand that one. You can't argue like that, okay? Now, we are talking about tangent to the plane at that point, and there are infinitely many tangents. Just have one tangent, rotate that one, that will become a plane. Am I right? Are you getting my point? But only one normal. What is that normal? Gradient at that point. Is that okay? Find the gradient, okay? So choose each option, take dot product. Which dot product will give 0? That is the vector which is perpendicular to that one. The vector that is perpendicular to that one is a tangent vector or parallel to the surface. Quickly do that one. I'll give options. 6i cap minus 2j cap plus 5k cap. 6i cap plus 2j cap plus 5k cap, okay? C. Minus 6i cap minus 2j cap plus 5k cap. First take gradient. Just imagine this is pi of x comma y comma z is equal to c. That's a family of family of curves, family of surface. Everything is coming. This is family of surface. Pi of x comma y comma z equal to c. Okay, gradient, and find gradient at 2 comma minus 2 comma 3. Quickly. Two minus 2 minus 4 minus 8 plus 6. Minus 2x cap plus 4y cap plus 4z cap. Which dot product will give 0? First one. Yeah, then you are lucky because you are going to start the trial and error by the first one. Am I right? First one, sure? Yeah. Yeah, again, in 30-second question, he's asking the same question. Possible unit tangent to the surface. Okay. Yeah, so that is correct word. Okay. Tangent to the surface is the correct word, not parallel to the surface. Okay. Because there are infinitely many, there are infinitely many tangent direction to the surface, but parallel is not a good word. Tangent is the good word. Okay. Yeah, do the 30-second one also. Okay. And in some other question, I think which question I don't remember. Yeah, I mean our dynamics question. Okay, electromagnetic waves. In electromagnetic waves, not electromagnetic waves, the electric field traveling from, I think electromagnetic wave traveling or whatever. Okay, so in that one, you have to use this concept to find normal to the surface. To find, to apply your boundary condition, you need component of the electric field normal to the surface, parallel to the surface. Am I right? Then you have to use this concept to find normal or parallel to the surface. Okay, that kind of question is designed, interlinked. You should know this concept where you have to find again unit normal to the surface or tangent to the surface. Again, there are many tangents. Okay, so there are many tangents to the surface. You can find tangent plane actually. So then along with that one, you have to find, you have to take component along those directions. Okay, let us discuss that question. Okay, so again we shall, so today is 8th, am I right? Today evening again we shall spend on electrodynamics. Okay, now I am going to upload some more question on electrostatics. After that I am going to option D, not option A. I think then I have done small mistake. This one? Minus 5? Okay, this was minus 5. Yeah. This is 6 only. This is minus 5. Then you are again, look at here, they will keep their answer in the option D. Isn't it? So that you start with this one, you spend some time to get your answer in trial and error. That is the psychology. If I design the question, I would also do that, isn't it? No, don't keep the answer in the first one. You have to first check first and last one. You have to start from the last. Is that okay? If this kind of question, you have to start from the last. I mean, this question, it will not take much time. But some other question where if you want to do trial and error, then yeah, better to start with the last one. Okay, it may work.